Good morning, guys. Welcome to our operational research lab one. We will be doing decision tree analysis, right? So the software we'll be using for this lab is the QM for Windows software version 5, right? So now under under QM, right, we have different modules, right? So on the left side, this side, we have different modules. So now, in this case, since we're doing decision trees, we're gonna go under decision analysis, right? And then we're gonna select the decision tree, right? So under the decision tree, as you can see, right, there's objective function, which is to maximize or minimize the cost, right? But as it stands, like you can either choose here whether you're minimizing or maximizing. You are maximizing, right? But it doesn't necessarily matter because even after you press OK, right, you can still modify your objective, right? So now I want to take you through like how to work around the software, right? So as you can see, this word right there, decision node word, right? Let's say, for example, I want to add branches, right? I can just come here and then add branches, right? And then let's say, for instance, I want to change this maybe into a decision node as well, right? I just come here, click on it, and then I can change it into a decision node, right? And then let's say I also want to add three branches now instead of two. I come here and then increase the number of branches and then make sure I click on it and then I press here, right? And then since this is a state of nature, we since like let's say now if I was about to let's say add a state of nature right here, right? In a state of nature, I can modify or write my whatever my probabilities are on this side or even the cost or profit, right? And then even for a decision, I can write if let's say if there was the cost for a particular decision, I can write here, right? Then if let's say I want to delete a branch per se, I can just come here, click on it, and then just remove it. QM allows you to delete branches, so I can delete the branches like this, right? So that's how you work your way around the software, right? But now I want us to now start and to start working around the software, right? Or start doing the question, right? So the question that we'll be doing is lab question one, right? About the Super-Cola company. So now here they're saying the Super-Cola company must decide whether to introduce a new diet drink, right? And then they're saying, so now as I was saying here, they're saying the Super-Cola company must decide whether to introduce a new drink, right? So they're saying the management feels that if it does not introduce the new diet soda, sorry, they're saying management feels that if it does introduce the diet soda, a maximum, it will yield a profit of 10 million if the sales are around, if they sell 100 million bottles, right? And then a profit of 2 million if the sales are around 50 million bottles sold, or they'll lose 20 million if they only sell 1 million bottles, right? So as you can see here, the Coca-Cola company must decide, right, on whether to introduce or they must introduce a new diet soda, right? So so now here they're giving you the cost of if like they do introduce the diet soda, right? And then they sell a particular amount of units. This is the different which means like for example, first if they sell 100 million bottles, they wanna make 10 million profit, 2 million, if they wanna make 2 million if they sell 50 million bottles, or they will lose 20 million if they sell 1 million bottles, right? So now they're saying Super Cola can decide to advertise the product ahead of the launch, and then the marketing will cost the company 500,000. If the marketing campaign is successful, the probability that the sales will be around 100 million is 0.5, and the probability that the sales will reach 50 million is 0.4, and the probability that the probability that the probability that the sales will be around 1 million is 0.1, right? And then they're saying if marketing is unsuccessful, the probability that the sales will be 100 million is 0.2, and the probability that the sale will reach 50 million. The probability that the sale will reach 50 million is 0.4, and the probability that the sales will meet around 1 million is 0.4, right? So, and then they're saying without marketing, the company believes that the probability that the sales will be around 100 million is 0.4, and the probability that the sales will reach 50 million bottles is 0.4, and then the probability that the sales will be around 1 million is 0.2, right? So now they are deciding on whether to introduce or they shouldn't introduce a new diet soda, right? So now, initially, like they said, like before they launch the product, right? They can either they should advertise ahead of launch, which means now that before like they introduce the drink, they want to do some advertising, right? And then in that advertising campaign, right, it will either be successful or unsuccessful, right? So now here initially we'll have two decisions, right? Which means we'll have two branches coming out, right? Where now they have to decide on whether they do advertising or they don't do advertising, right? So I'm just gonna say, so they can either do advertising or no advertising, right? So now, since so now if they're saying the marketing or the advertising costs 500,000, so also come back here, right? Since like the advertising will cost 500,000, which means here they'll lose 500,000, right? Which means they spend 500,000 to do advertising. So we have to minus the 500,000, right? So this is how we minus the 500,000, right? And then, so now, as you saw, they said like if they do the advertising, right, the campaign can either be successful or unsuccessful, right? Which means we'll have, so now the advertising being successful or not successful, it's a kind of, how can I put this? It's something that may happen or not happen. So the advertising campaign that they would do would either be successful or unsuccessful, which means it's a probability or outcome, right? Which means we'll use a state of nature, right? So from a state of nature, we'll add two branches, right? In those two branches, the advertising may be successful or unsuccessful, right? So now the advertising may be successful, right? Or it may be unsuccessful, right? So now here they are saying if the so now after the advertising successful or not successful, so they are saying if the marketing campaign is successful, right? The probability that the sales will be 100 million, this 100 million bottles is 0.5, probability that this will reach 50 million is 0.4, and the probability that the sales will be 1 million is 0.1, right? Which means after if the marketing campaign is successful, right, they'll have to make a decision Now, right, on whether to introduce or don't introduce the new drink, right? So now they'll have to decide on whether, let's say they had a successful marketing campaign, right? They'll have to decide on whether to introduce, introduce. So they have to make a decision in order to introduce the new drink, which means they'll introduce the new Diet Coke. And then here, the other decision is that they won't, they won't introduce the Diet Coke, right? So after they do the marketing, they'll have to decide on whether they they introduce the new Diet Coke that they introduced. But if we go back here again, they are saying, so now here, if we go back here, they are saying that, oh, okay. So I want to clear something up, right? So here, since like they didn't tell us what's the probability of the marketing campaign being successful or not successful, we assume an equal chance of everything, right? Which means here, right, we'll have our probabilities as 0.5, right? So there's 0.5. So if they didn't mention it to us, right, we're gonna assume that there's a 0.5% or 50% chance that our campaign is successful. And there's also a 50% chance that our campaign is unsuccessful, right? So here, as I was saying, they have to make a decision on whether to introduce or don't introduce the Diet Coke, right? So now, if they don't introduce the Diet Coke, right, here, right, it means they won't make any money. So their profit will be zero, right? So they'll make zero from it. And then if they introduce the new Diet Coke, right, if we come back and look at it here, so they said if let's say they introduce the Diet Coke, right, they can either, there are three likely outcomes that may happen. They may either sell 100 million bottles or 50 million or 1 million bottles, right? Which means here in this instance, after if they introduce the new Diet Coke, right, they will have they will have three possible outcomes, right? Which means we'll increase the number of branches to three, right? And then we'll change this into a state of nature or an event node, right? And then so now in our first event, they said first they may sell 100 million bottles, right? If their marketing campaign is successful, 100 million bottles, or they may sell 50 million bottles, right? So type 50 million, or they may sell 1 million bottles, right? So now if we go back here, right? So since our marketing campaign is successful, right? So since our marketing campaign is successful, they said if the marketing campaign is successful, that the sales, the probability that the sales will be around 1 million is 0.5, right? So we come here, right? So if the marketing is successful, the probability that we sell 100 million bottles is 0.5, and then you come here, we enter our probabilities as 0.5, right? And then here they said the probability that their sales will be, if marketing success, the probability that their sales will be 50 million is 0.4, right? And then the probability that the sales will be 1 million, right? The probability of that is 0.1, right? So one thing you'll notice that the probability of the three branches, they add up to one. So they must always add up to one every time, right? And then, so now here, they're saying, like, if you go back here again to the top, they said like if they sell 100 million bottles, they'll make 10 million, right? So now this which means like if they sell 100 million bottles here, the most likely profit that they'll make it's a 10 million, right? But then since you already spend this 500,000 on advertising, right? We'll have to eliminate the 10 million that they'll make minus the cost of advertising, right? Which means here the most likely profit that they're expected to make will be 9.5 million, right? Right. And then here, they're saying like if they sell 50 million bottles, they make 2 million, right? So now since they already spent 500,000, 500,000 on advertising, which means here will also subtract that 500,000 from the 2 million, which means the expected profit will be 1.5 million, right? They'll make 1.5 million. And then if they sell 1 million drinks, right, they're expected to lose 20 million, right? But they're going to lose that 20 million plus the 500,000 that they spend on advertising, which means here they're expected to lose. So it's a negative since it's a loss. It's a negative 20,500,000. Yes, like this. So now here, since since they're not gonna since they won't introduce no diet coke, right? While they've spent 500,000 here, the expected loss here, right? It's that they will lose 500,000 from the marketing, right? And then if the marketing is unsuccessful as well, they can also decide, right, on whether to introduce the new diet coke or not, right? Which means here they'll also have two decisions, right? Whether to introduce or not introduce the diet coke, right? So here it's the introduce the new diet coke or they don't introduce it, diet coke, right? And then if they introduce as well here, right? And then they said if the marketing campaign is successful and then they decide to introduce the new diet coke as well, right? They can either sell, they can either sell. So now, as I was saying, right, they can either now decide, like if the marketing campaigns are successful, they can decide on whether to introduce or they shouldn't introduce a new diet coke, right? If they don't introduce a new diet coke, means that they will lose the 500,000 that they've done from marketing, which means here it will be a minus 500,000, right? And then here, right, if they introduce a new diet coke, right? So now, as a as I was saying, right? So if they introduce the new diet coke, right? They can either as well, right? Even if their marketing campaign is unsuccessful, as they said here, if the marketing is not successful, the probability that they will sell 100 million bottles will be zero point 0.2, and the probability that the sales will reach 50 million bottles is 0.4, and then the sales that the probability that the sales will be 1 million is also 0.4, which means that even if the marketing campaign is unsuccessful, right, and then they still do decide to introduce the new diet coke, right, they'll have three likely outcomes, right, which means we'll have three branches right here, which means on the so before we continue, you change this into an event node, right? So it's important that it's always an event node towards the end, right? And then so if they introduce a new drink, right? As like they're saying here, there's three likely outcomes that may happen. They may either sell 100 million bottles or 50 million bottles or 1 million bottles. That's why we have three branches here from after when they decide on which drink to whether they should introduce or they shouldn't introduce the drink, right? So in the first branch, right, it's they'll either sell 100 million bottles, or they may sell 50 million bottles, or they may sell 1 million bottles, right? And then here, they're saying the probability, if the marketing is unsuccessful, they're saying the probability that they'll sell 100 million bottles is 0.2, right? Which means our probability here will be 0.2, right? And then they're saying if they sell 50 million bottles, the probability is 0.4, right? Of them like selling the probability of them selling 50 million bottles, right? If they're given that the marketing is unsuccessful. So here we're gonna have 0.4. And then lastly, they said if the probability that they'll sell 1 million bottles is 0.4 as well, which means here we'll have 0.4, right? And then going back like to here again, right? They gave us the cost of how much they are expected to gain or lose if these different alternatives come through, right? So if like again, if they sell 100 million bottles, they'll make 10 million, right? So which means here they'll make 10 million, right? But since they've already spent 500,000 from marketing, right? So you're gonna subtract the money that they stand to make, which is 10 million minus the 500,000 that they've spent on advertising, right? Which means here the expected, so their probability here is 0.2, and then the expected profit that they are expected to make would be 9,500,000, right? And then here, if they sell 50 million bottles, right, the expected profit that they're supposed to make is 2 million, right? But since they've already spent the 500,000 on marketing as well, the expected profit that they're supposed to make here will be 1.5 million, right? And then here, if they sell, if they sell, and then here, if they sell 1 million bottles, right, the expected profit or loss that they're supposed to make, they're saying they'll lose 20 million, right? So, but since they've already spent 500,000 on advertising, right, they'll lose the 20 million plus the 500,000 they've spent on advertising, which means here in total they'll lose 20,500,000, right? And then we are done with our like on our decision branches where they do advertising, right? And then coming back to this side, let's say they decide not to do any advertising, decide on whether they can either now, if they don't do advertising, they can either start on deciding. So we'll have a decision note. They'll have to decide on whether they're introducing or they're not introducing the new drink, right? Which means here they'll have to decide on whether to introduce the new drink or they don't introduce the new drink. Right, cool. Yeah. Right. So now if so now here, right, if since they didn't do any marketing, right, they decide to introduce the new Diet Coke, right? So if they introduce the new, if they, so let's start, I wanted to start here. If they don't introduce a Diet Coke, right? Since they didn't do any advertising and they didn't do it, like they didn't introduce a Diet Coke, they won't lose anything. So here, the expected profit or loss they're supposed to make will be zero, right? If they don't introduce the Diet Coke. But then if they introduce the new Diet Coke, there are three possible alternatives that may occur, right? They may either now, so now before we don't change this into an event node, so now here, if they if they if they introduce they can here if they introduce the new Diet Coke, they may either sell 100 million units, right? Which means 100 million bottles, right? And then they may either or 50 million bottles or 1 million 1 million bottles, right? So now here they're saying without marketing, the company believes that they can make the probability that they'll sell 100 million bottles is zero point 0.4, right? Which means here our probability of selling 100 million bottles without marketing will be 0 0.4. And then the probability of selling 50 million bottles without marketing will be also 0 0.4. So our probability here will also be 0 0.4, right? And then the probability of selling 1 million bottles will be 0 0.2, right? Which means here our probability will be 0 0.2 if they of them like selling it 1 million bottles without doing marketing or advertising, right? And then so 0 0.2 is supposed to be here, right? And then going back again, right? Going back to the top, since like they're saying if they sell 100 million bottles, they'll make a profit of 10 million, right? So here, since they didn't do any advertising, right, they will not lose anything from their profit, which means here they will make 10 million exactly, right? Since they didn't spend any money on advertising, right? And then here, right? If they sell 50 million bottles, they'll make a profit of 2 million, right? So as like similarly, since they didn't spend any money on advertising, the expected profit here they wanna make is gonna be 2 million, right? And then now the if they sell 1 million bottles, the expected loss they're supposed to make is gonna be 20 million, right? Which means here they'll lose 20 million just 20 million because they didn't spend any money on advertising, right? Which means here they lose 20 million, right? And then now, from now, since your decision tree is complete, now you can press. So there's an error. They're saying no 2. So here, this node 2. Right. So it's right. And then now you press node 11. Okay. So now I'm just trying to see what's going on. Okay. So here they're saying the probability sum up to. So let me check if they said the marketing is unsuccessful. So here there's supposed to be 0.4, right? And then now let me just double check. Supposed to be 0.4. Okay. Then now I think my decision tree should run. Right. So now after you press solve, right, you can get your EMVs, right, and now you can make a decision on whether on which decision on whether like the company should make, right here. So now they can make an optimal decision by determining or the MV has been determined for us. We just have to now make a decision. So that's how you do decision trees in using Excel QM.